All right, number one, a particle moves along the x-axis so that the velocity is given, so v of t is whatever. How do I find position? How do I find out where the particle is at any given point? Okay, so I would write an equation, x of t representing position is what? The integral of velocity, that's fine, right? But this, and we're okay here if we write it like this. The position is the integral of velocity. That's true. This is an indefinite integral, right? So when I have my answer, when I'm done with this, I'm going to put a plus c, yeah? And to find the plus c, you'd plug in your initial condition to find c, yeah? But do you know the antiderivative? Do you know the integral of velocity in this case? No, you don't. And if you do, that means you are a genius or you use your calculator. So we have to write this as a definite integral instead. So what is our lower bound of the definite integral if I want to go from velocity to position? What goes here in general? Kind of the x value, not the, because this is x. In this case, it's the t value of what? All right, I'll give you an example. If I say f prime of x, if I give you whatever f prime of x is, and I say f of 3 is 7, what is f of x equal to? F of 3 equals 7 is just a point on the graph of f. So what's f of x in general? It's the integral of f prime plus what? 7. Plus 7. So in order for f to give me a value of 7, that means this value has to be what? 0. So how do I clear it out? How do I make this disappear? 3 to 3 would make this 7, right? So this shouldn't be x, this should be t. Okay, so how do we say this? The function is equal to the integral of f prime, where the lower bound is what value? What is that? That's the initial condition. That's the x value's initial condition, right? And then over here you have plus the y value, right? So what is the initial condition in this case? Three comma 2. X of 3 equals 2, right? It says the position is at the particle to position is at 2 when t equals 3. So what's the lower bound here? 3. What's the upper bound? What's the variable? T. Because that's t, this has to change. What do you want to change it to? No, we already got x. Whatever, it doesn't matter, whatever you want to call it. It's just a dummy variable, doesn't mean anything. And then what? Plus 2. Okay, so that's my equation for position. Now, how do I find the position? What am I looking for? Where was the particle when it started moving? So what am I looking for? X of 0, because that's the beginning of time. That's an interesting concept. 3, 0, v of m dm, and then plus 2. So if you didn't do it, do it. What is x of 0? Plug that in your calculator, get an answer.
It is negative.
Negative what?
17.0991.
Is that right? So plus 2?
Yeah.
Okay. So x of 0 is negative 15.099?
Yeah.
Okay, now, understanding what's going on here, right? If I just take the antiderivative of velocity, am I creating a position function? Am I finding position? What am I finding when I take the integral? The what? Antiderivative, yeah, but that's the word. Who said it? Displacement, right? Net area is how much the particle moved. So to figure out where you are, you have to figure out where you start. You started at 2, and you moved 17 to the left, right? You guys okay with this? I don't believe it. Oh, I just made this up. This one here. I was just using this as an example. Okay, but this The initial condition was 3, 2. Now, initial condition, you would think that this has to be 0. But it doesn't matter as long as you have a point on the graph. Remember, we talked about this. If I say f of x equals x squared, right, versus f of x equals x squared plus 3, what's the difference? It's just a vertical shift, right? So if I said, for example, f prime of x is what? I don't know. 1/2 x, 1/2 x, right? How would I get to f of x? Take the integral of both sides, yeah? So we get f of x equals, let me change this. So it's 2. All right, so you get x squared plus c. This plus c tells you your vertical shift. So as long as you know, here's the parabola, here's x squared, right? This is x squared plus c, this is x squared plus c, this is x squared plus c. What do you need to know to find where the parabola actually is? Any point on the curve. It doesn't matter which one as long as you have one of them, right? So it doesn't matter if it's the initial one or any other point, okay? Are we okay with this? Sure. Well, in a way, it says where was the particle when it started moving. So we would say, well, where did it start moving? At the beginning of time. And the interval of time is from 0 to 8, so the initial time is 0. Okay, number 2. How do you know when the particle has its greatest speed? Something about absolute value, because the velocity, or speed is the absolute value of velocity. Okay, when the position is increasing fastest. But I didn't give you position, I gave you velocity. The greatest positive or the greatest negative, however you want to say that, right? Either what are we looking for in terms of velocity if I want the greatest speed? I'm looking for the highest velocity or the lowest, and then you compare them, right? So how do you find, what are those called? Max and mins of velocity. How do I find the max and min of velocity? So let's take the derivative. So v prime, or acceleration if you want to call it that. What is the derivative? Cosine of natural log of t plus 1. That's all? Say it again. I'm looking for the maximum and the minimum of velocity. How do I find the max and mins of function? I take its derivative. I'm not finding the max of position. I'm finding the maximum of velocity. So I have to take the derivative of it. All right, so what am I going to do with that now? Let me rewrite this. Set it equal to 0. Figure out when it does not exist. Figure out when it's equal to 0. And consider endpoints. So when does it not exist? T equals -1 because of this. What about up here? When t equals -1 because you can't take the natural log of 0, right? But the domain is 0 to 8. So we're going to set this equal to 0. So do it if you didn't do it. You need to practice this and figure out when this happens. So t equals, what is it? 3.81? 3 decimals. You guys are killing me. Why do I? So is that the only one? Okay, so we want critical points. Critical points are when what? T equals 0, 3.810, 8. So we'll set up the number line, 0, 3.810, and 8. This is when v prime is 0, or acceleration is 0. This is endpoints. This is endpoints. Looking at the graph, what is the sign of v prime? What is it? Positive and negative. So what does that make this? A minimum, because the function is increasing from the end, right? Minimum. What's this? Max. And this one? Minimum. So is it good enough? Is it good enough to say, oh, that's the maximum of velocity, so therefore it's traveling the fastest there? No, because you could have a negative velocity and then therefore have a greater speed, right? So how are we going to figure out which one of these has the greater speed? To what? to velocity. So let's find all those. V of 0, V of 3.810, V of 8. What's V of 0? So 5 there. What's velocity of 3.810? 6? Is it really just 6? Okay. What's V of 8? 801? So where is the greatest velocity or the greatest speed? All right, it is asking for what the greatest speed is, or where is it? When is it? So it's t equals 3.810. Whew, that was torture.